And then let's look at that angle of theta there. I think I did alpha that corner before. Let's do this corner this time. So that would be cosine theta I hat negative. We'll come back to the negative in just a second. Plus sine theta j hat. Now there is a small error on the board. If you take it literally, if you take the approach of I'm doing this, I know what I'm doing, I understand what numbers I'm going to put in there, fine. But if you're looking at this and going, all right, I'm going to plug in -3 microcoulombs there and so forth, then you're going to run into trouble. Similar to what we did before, I know the direction based upon thinking through it. I know that it's going to be attractive. Q2, this right here needs to be the magnitude. So this Q2 here would be a +3.
Yeah.
Or you could ignore this -3, ignore that 4 for right now, do the whole thing, just assume they're positive, and then just plug the -3 in at the end. That also works. And one of the things I've realized with so many choices is students start mixing and matching the different techniques. Well, students and adults, you know, think about when your parents have worked out physics problems during dinner and they were doing 2 different techniques for solving something.
Of course.
Then it leads to fights.
Divorce. Yeah, that was
Transfer
really
mommy and daddy got divorced.
I was just trying to eat my broccoli.
Stop arguing about physics. It's not going to work properly with a knife fight. All right. So let's plug in what we do know. Q2 is, oh, I need to know, I have that distance, okay. I'm going to label that L. Make it a lowercase l, just for fun. That seems fun, doesn't it? I'm finding x like that, so this distance right here is some value of x. All right, so we have k, q2, dq. We've got this relationship right here is lambda dx over r squared. That's going to be, so I've got this triangle right there. This is L, 1 meter. This is X. This is R. I have a relationship between R, L, and X, assuming Pythagoras did not lie to us. So this becomes X. Actually, I'm going to leave it as R squared for right now. But I know that R squared is equal to X squared plus L squared. Times the cosine of theta. And just to settle that, let's just put absolute value marks around that. All right, so cosine of theta, that is the adjacent over the hypotenuse. So that is -x over r I hat. And then this is plus L over R j hat. Now we have the numbers here. You could actually calculate the angle the way we did in the previous problem, but we don't have to.
We don't?
No, because in essence what you do if you find that angle, you're going to be doing some relationship of these three, doing an arc or inverse trig function, finding the angle, and then you're going to be taking a trig function of that. So this cuts out a step.
Cool. It's pretty simple.
But I recognize some of you probably have some sort of calculator fetish, and so, you know, just do the extra work if you want.
So plug.
I'm sure there are people out there with that, but. The reason why I kept this as R is because I knew I was going to end up with an R here, so we're going to end up with an R cubed. which we did yesterday, we just wrote it differently. So this is K times the absolute value of Q, lambda dx over times negative x over r cubed, I hat, I'm just distributing. And then we have LK, absolute value of Q2, lambda dx over r cubed, J hat. And now everyone's favorite, we're gonna do some integration. Let's take the I hat piece first. So F in the X direction.
What is in front of the K there?
That's an X.
Yeah, because we have this X here, that, I put it down there.
No, I mean on the other side.
That's an L.
That's an L.
Oh.
Or an elongated E. So much better. So F in the X direction would be the negative integral of, do that differently. Let's plot the constants. So K, absolute value of Q2, lambda, the negative, and I hat, times the integral of x dx over r cubed, which is x squared plus L squared to the 3 halves. We have only a single variable now, x, so we can do limits of integration. And what are the limits of integration for x?
Do we use table of integrals? Oh, for the limits, my mistake.
It's -2 to 1.
1.
Yep.
Yeah.
Negative 2.
What was that?
You can work to pick up on that.
So, Dr. Fox, I'm a little confused. So, you started out by splitting it into sections, but now we're just gonna, because we took the information from the section on the left, we can just integrate the whole rod.
Yes, yeah,
Great.
because DQ is just some random location on the rod itself or the line.
Okay, thank you.
Yep. All right, so how do we solve this?
Get a table. Look it up.
That is indeed one way of doing it. There is actually a simpler way, I think, but it depends upon your mindset.
So we get.
Is it a to the,
Think about what we did yesterday?
yeah,
Yeah, that's gonna work on the J hat part, not the I hat part. And because we have X in the numerator, that gets messed up.
Oh, I do see it. It's just dx in the numerator.
Is that table of integrals over there?
Yeah. Am I not gonna find it?
Oh, it might be there, I don't know, but there's a simpler way that, one of the early techniques for doing integration.
Show us. Show us how.
You can use sub.
Yes, you can use substitution for this one. So like u be x squared plus L squared.
big brain.
So
It's been 10
du
years since I took Calc 2, and I still
X
got
dx. I do recognize that, you think a lot of high thoughts up here, and then occasionally something, it's like playing D&D and it'll be on a level 50 and someone throws in a level 1 monster,
Something's afoot.
What's D&D?
Dungeons and Dragons. Satan's game.
Open up a can of worms.
Am I gonna fail now?
So we
No,
take out,
I know enough to make D&D references, but,
we take out the L because that's a constant.
yes, L is a,
Great.
yeah.
X's cancel.
So x dx is 1/2 du, so then we get negative k q2, absolute value, lambda over two I hat du over u squared. And if you wanna put in the limits of integration based upon the value, based upon u, that's fine, or take to the next step, put x back in and use those limits, it doesn't matter. But what is this? Or if you prefer, u to the negative two du.
What about the 3/2?
Yeah, I was wondering.
Yeah,
So
so
it's square.
don't we still need that?
Oh,
Oh,
so you wanna do it correctly, is that what I'm hearing?
no,
Whatever,
whatever.
thank you.
I see you.
And we all know the moral of that story. So anyway, what is this?
Are you asking for the, are you asking for the derivative?
Yeah, well, for the integral.
So is it gonna be minus 3 over 2 u to the derivative?
U to the negative half,
Yeah.
no, 2 times u to the negative half, negative, no.
Negative 2 times u.
Thank you, thank you.
That's what you're saying?
No, negative 2 times
Negative 2/3.
u to the negative half over 3.
Over three?
Yeah, not over 3.
Oh, just over 1.
All right, when you're doing a derivative, then if this were a derivative, we'd multiply by negative 3/2
Yeah.
and then subtract one. Doing the integral, we do the opposite, we add one and then divide by that. So you add one first to get negative 1/2, then divide by negative 1/2, get you negative two.
And then we also, can we resubstitute u?
All right, so I got negative k q 2 lambda over 2 I hat times negative 2 times the integral. So we got 1 over the square root of x squared plus l squared. Oops. We're not integrating the second time. And that was from negative 2 to 1. So now we're at the looking at numbers phase. We can cancel some stuff out. And red doesn't show up anymore. Perfect. So that becomes plus, that's plus, that 2 cancels out with that 2, that's just a straight mark. So I have 9 times 10 to the 9th times 3 times 10 to the negative 6th times lambda, which is 4 times 10 to the negative 6th divided by 3. I hat times this puppy right here, which is 1 over the square root of 1 plus 1 minus 1 over the square root of 9 plus 1.
And
How
also,
easily can you see those, right? Not
line
well.
over here.
It's a little tricky.
Yeah.
What is, do we have a value for lambda?
Lambda is just Q over L, it's the,
Charge density.
it's the
Which-
4 microcoulombs divided by the 3 meters.
Oh, okay.
That's where, oh, couldn't see it. It was in the wrong color. That's where this comes from, this is lambda.
Okay, thank you.
Why did you get rid of the negative 2 in the interval?
There was a negative already here, and then canceled out with that negative.
Why did you get rid of the 2?
It canceled out with that too. I had a 2 on the bottom here from my U substitution. Let's get rid of the red here.
Oh, so that canceled out the 2.
Yeah, so I had that 2 right there. So that 2 came from the U substitution, and then that 2 came from here, and they canceled out.
Okay.
And what's in the denominator on that behind the I-hat?
Over here?
I know that's 1 plus 1 square root.
Yeah, so it's x squared plus L squared, L is one.
L is 1, okay. But isn't X 2?
X is negative two. Oh,
Negative 2.
so that should be,
Oh, wait, no,
Oh, no, no,
that's
no, that
correct.
should be 1.
Yeah, that's correct, okay.
over here, this is my mistake, that's 4 plus 1.
Okay.
So that's 1 plus 1.
Oh, we're getting it.
1 plus 1.
Don't ask me.
Not that I'm cynical, but this is so much better than a marker board.
Is it really?
You may take it as sarcasm.
Let's say, I think your sarcasm is off.
Hey, I warned you in one of those videos.
Of course,
All right, so at this point, it's a calculator exercise, so we got, so in parentheses here, 1 over the square root of 2 minus 1 over the square root of 5. This will produce a negative number, because I know ultimately it's gotta be in the negative I-hat direction, so we better end up with a negative at the very end. And we'll get some number of, no doubt, incredible significance.
I got negative 9.36 times 10 to the negative 15 newtons.
I'm not buying that,
Okay,
because that's 10 to the 9th, and those are 10 to the negative 6, so right there we have a 10 to the negative 3. I'm multiplying 9 times 12 divided by 3, so 9, so that's 36, so it'd be a 10 to the negative 2 divided by this, yeah, there's no way that's a 10 to the 15th, so positive or negative.
What does the denominator say? Denominator?
oh,
Correct.
just whatever value I just told you, multiply that by, I just completely missed the 10 to the negative 6.
That whole left side of the I-hat, that's gonna be 0.036.
0.036,
Yes.
okay? And this piece?
That's above my math.
I might have a slide rule in my office, if that would help me.
Okay.
Or just do the square root, the long end, you know, on paper.
No.
You were taught how to do square roots from scratch, right?
No.
No.
No, they did, but you never
Can we
even
go over that?
I'd have to refresh my memory. It's been a long time since I've had to do square roots by hand.
Okay, negative 0.42 newtons in the I-hat direction.
Oh, negative 0.42 is the whole thing.
Yeah.
All right, so negative 0.42 newtons. I have.
I have to do
Yay, we're halfway done.
That wasn't much work.
So that's half the problem.
Alright,
We've got confirmation on this?
oh,
Okay, so I know earlier you mentioned it has to be a negative, right?
Right.
But then 1 over the square root of 2 minus 1 over the square root of 5, that's gonna be positive, isn't it?
Yeah, that's well.
Oh.
That's where I'm confused at.
I think because the,
Right?
I don't know if this has anything to do with it, but maybe because the charge is in, it's only the magnitude of charge Q2, perhaps?
Because we've got a minus sign here, because we thought through it, we know it's gonna be in that direction. So we got the minus sign there. That minus sign translates down to there, which then shows up here.
Mm-hmm.
Then we counter it out.
Lambda is a positive number, so then no negative sign shows up here. We get the negative sign showing up here, which cancels out with that one.
I have a number, I just don't like it.
What's your number?
My number is 0.009.
I'm getting
That's
that.
what I got.
For which? For the I-hat?
Yeah, for the J hat, or
I had.
Oh, yeah.
is it I hat or J hat we're doing?
I had.
Okay.
The J one is like the weird.
Yeah, I got that as well.
But that minus sign. Minus signs are the bane of my existence. Alright,
Let's just acknowledge that the minus sign may or may not be there.
I redid the math, and I also got 0.009. Do we just change that answer, make it negative anyways, because that's what we know from the picture?
I suspect that will do it, but there's, I'm gonna have to think about why that messed up. And then the J hat, let's just go ahead and finish that. Any questions on this, because I need to erase all this? And then well, you're doing your activity for the
lab.
for the lab. I'll try to figure out what happened with minus sign.
Is this a write-up lab?
It is, there will be something written, I'll explain it, it's not I call it an activity more than a lab.
Okay. Do we do the J-hat?
Yeah, we're about to do it. All right, any questions about this, other than what happened to that minus sign you claimed that it should be there?
I didn't claim it at all, I'm just
I
saying.
claimed it.
Yeah.
Oh, sorry, I thought you claimed it.
Alright. No, not that one, this one. Alright, now the J hat piece, this will look a lot similar to what we did yesterday. So we have, Fy, LK, Q2,